so that anybody who happens to misses tonight but would like to see the recording can now see the recording that I'm now going to make. Okay. So having said that, let me jump into tonight's session here. Yes, I am sharing my screen here. So let me talk about some things. First of all, I'll give you guys a minute to go ahead and copy down what you see on the screen here. It's a review. This is a slide that's kind of a review slide about percentages. So, but I thought I would. Okay, let's talk about what we're looking at here on the screen. This is a review slide. Okay, so I'm gonna plug in my tablet here so that I can. You won't be able to see me, but you will be able to see. I will be able to draw much better. So if I do this, um, what I have here is there's kind of two ways if I'm focusing on reviewing here, okay, that we've learned in this course to find percentage of something, okay. Um, if they ask you to find, what is a 2% increase on $62,000, okay? What's a 2% increase, okay? The first method is to multiply this 2%, okay, that they give you, turn it into a decimal by moving the decimal point 2 places to left, so it's 0.02 times the 62,000, and you get $1,240. That's 2%. But if they wanted to know, okay, what is the total amount I have to pay back now? Okay, the first method is to do it this way. Just multiply the percent times the total they gave you, get a number, and add it back to the total that they originally gave me. If I write down here, and you can add this to your notes, okay, the original amount, okay. So I found the percent, and that's this 2% here. It's right here. And I add it to the original, and that gives me my now total, put a little comma here, amount that I owe or something if I had a loan, okay. So and the second method that's a little bit faster, you just have to do a little bit of thinking up front, okay? You pause for a couple of seconds and think about it is, if it's 2%, of something, so let's say it's in 2% increase or something, okay? That would be, well, how much is 100%? It'd be 1.0. That'd be 100% of something, like one times something, right? So a 2% increase would be 1.02. That's the 2% more than 100%, okay? So if I had a 2% increase, that's like 102%. If I multiply 1.02 times my original, in one step, you'll notice I got the same answer here, okay? I got the same amount, okay? Let's say that you had a 15% raise on something, and you wanted to know how much money I'm going to get at the total. And if it was 62,000, okay, and a 15% raise, so it would be times 115, okay, 1.15. That's 115% right there if I put percentage in there. That's 15 more than 100%. Okay. Now, let's say that they said you had a 3% discount, went down 3%. What would that look like? If you remember from a couple weeks ago, I could do this: 62,000 times what's 3% less than 100%? 0.97. That's 100 minus 3 is 97. That would give me a 3% discount, okay, if the price is going down on something, okay? So just know, now you could just multiply 0.03 times 62,000 and get an answer, and then take that answer and subtract it from 62,000 to find out the new percent. But method 2 is a little faster if you can figure it out in your head. what that percent actually looks like as a decimal. Okay. All right. That's a review concept, but it's going to help you tonight as we start looking into our next few concepts, which is finding percent decrease of something. Okay. So I'm going to pause my recording because I just want to give you guys time to write all this down. And hopefully I've got two ways I can solve this. Kind of the way I learned, I recall. First, I'd figure out what's 4% of this 279. If it's going to be 2% less, or I'm sorry. Yeah, it's going to be 4% less. So I would multiply my 279 over here on the left times 0.04, because that's 4%, moving the decimal point 2 places to the left. As a decimal, it's 0.04. That's 11. Okay, that's like 11 cents in a sense here, if I put a cent sign here. Now, that's what 4% is. I got to subtract that. That's what I'm going to do. 279, my original price. Okay. And I subtract $11, 11 cents. I get $2.68. That's how much it would cost in a year if it was 4% less. And so I'm going to underline less 3 times here because it's really important that you pay attention to what they're asking you to do. All right. Now, method 2, the second method to do this, like I said, is 4% less. So I'm thinking about 4% less than 100%. Well, if 100% is 1.00, that's 100%. Okay. What is 4 taken away from 100? 0.96. That equals 4% less. Okay. See how I just subtracted that 4%? So if I take my 96%, which would be 0.96 as a decimal, of is times, okay, 0.96 times my amount, 279, you'll notice I'm getting $2.68 is how much it cost. And in both cases, I got the right answer. So use whichever method is best for you. But just make sure you turn that percentage into a decimal correctly. All right, I'm going to move on, folks. Hope we're doing okay on this. Okay. All right, this is a real important slide. So I want you to take a moment and just take your time and copy what you see on the slide, because this is the kind of a key formula for this whole chapter. Okay, folks, so we've got our magical formula here that we've copied down in our notes, which is take the final value, okay, in a story problem. If they want to know the percent change, I take my final value minus my initial value, or the original, the starting value. This, you might even add to your notes, put this above it, start value. In fact, if this helps you, think of that as the start value. Think of this as the end value that you had in a story problem, okay? All right, so the ending value minus the starting value, get an answer, divide that answer by the initial value, which is the start value, okay? So here's a story problem. Let's take a look at this example we have on the screen here. If a population increased from 40,000, so I'm going to kind of model for you what I might do if this is a paper test or something. It's increasing. I'm just kind of making a note of that. I'm underlining the word increasing. It's not going down. It's not decreasing. It's increasing. Okay. From 40,000 to 45,000, find the percent change. This is what it's asking me for, is this thing called the percent change. Okay. And that's what this slide is all about. And this week, this chapter, excuse me, is about percent change. All right. So I'm going to plug it in my formula. I take the final value, which is, this is my final value right here, 45,000. That's my end value. I'll put end because that's quicker, okay? Hope that's okay with you guys. End value. And this is my start value, okay? All right. So I take my final value, which is 45,000, okay? and I subtract my initial value, okay, start value, which is this one here, it gives me this number right here, 5,000. Now, my formula says to take that number that we got doing this equation right here, final minus initial, and divide it by the initial, okay? So if I take my $5,000 here, I just slid it over here to the right, and divide it by, or put it over my initial value, my start value. So I'm going to draw a little arrow here. That's my start value right here, okay? That gives me 0 on my calculator. It'll look like this, 0.125, okay? Convert that to a percentage by moving the decimal point, as we learned a week or two ago, 2 places. And I got a 12.5%, okay? So it wants to know the percent change. The question asked me for the percent change. It changed, I'll rewrite this, 12.5%. That's how much, that's the percent change, okay? So this slide here is kind of like the key. The previous two were kind of reviewing some things, but this is kind of the key new concept for chapter 1.12, chapter 12. All right, I hope I've given you enough time to kind of copy that and absorb that. I'm going to move on, okay? Give you some more examples here, okay? All right, example 2. It might just help you to just kind of, I don't know, maybe copy just the numbers or something, but I've got a sales decreased, all right? Again, I'm going to model this. I'm looking at this as a reader. I hear this word decrease. I'm thinking minus, okay? It's going down from 80,000 units to 68,000 units. Find the percent change. In this case, it's really, I'll write this note over here, okay? It's really asking you for the percent decrease, okay? How much did it decrease? What percentage did it go down? All right, take my formula here. Final value, okay, went from this to that. So I take my 68,000. This is my end value, okay? Remember, I abbreviated. This is the final value. This is my initial value, which is now the start value, okay? So final value is 68,000 minus my initial value, and I get a negative. You'll notice, I want you to pay attention to this. I got a negative 12,000 units, okay? All right, because 68,000 minus 80,000 is going to give me a negative number. All right, take my answer and divide it by my initial value, which was 80,000, my start value. So I'm going to let somebody in the room here. I think they lost their connection for a moment. So I'll take my initial value, there's my start value, and I'm going to divide it into my answer. And I punch that in my calculator and I get 0.15, which is 15%, but it's going to be a minus 15%, okay? So it was a 15% decrease in units, or it changed minus 15%, okay? So once again, I'm modeling for you as I'm reading the story problem, I'm underlining or really highlighting in my mind, is it asking for increasing or decreasing? Because I want to make sure I write my answer correctly, okay? All right, let's look at another one just like this, guys, and take a look at it. Okay, another example, walk you through this here. Actually, I think that's about it. That is about it. Yeah, that's it for chapter 12. It's really all about finding percent increase and percent decrease. And again, I want to remind you, kind of like I'm not ending, but as if I was, this is my key formula here for finding percent of increase or decrease. I use that formula and I'll get it right every time. As long as I put the right things, subtract the right things, okay? Don't get them backwards and subtract your initial value from your final value and then divide the wrong thing into it. Follow this formula exactly to calculate percent increase or decrease. It's the same formula. All right. All right, I'm going to pause here and let you guys copy this slide down. So this chapter is, as I mentioned, is just mostly it's a bunch of new terms, what they mean, and then identifying them. And then there'll be a couple of little math concepts as well in chapter 13. Okay. The first term we have here on the screen here is this term called a constant. Okay. In algebra, a constant it's just a number. Okay. Numbers are called constants, and because they're the same, the value doesn't change. If you wanted to underline this in your notes. Okay. So examples are 1, 5, 8, -3, or 1/2. They're always a half is a half. Okay. -3 is always a -3 in a story problem or a math problem. So constants are numbers. Okay. Yeah, that's the simplest way to put it. It's another name for a number. Okay. And then we have something here called a variable. All right. Now this is a kind of a big key concept as we're leading into algebra here. Variables are letters. So you might want to underline it. It's letters. Okay. Like A or X or Y. And its value changes. Depends on the problem. Okay. Now, I happen to know that for some of you, right now, when you saw X, Y, and A, you got stressed. Your temperature went up, or your heartbeat did, because that was the moment in math when you started feeling like, I don't understand math. How can A equal 5 in this problem and 2 in the next problem? How are we supposed to know that, right? Let me just show you a quick example over here. 2A equals, let's say, 10. Okay. So 2 times A equals 10. You guys would all know that in this case, okay, A equals 5, right? Let's take another one. 2A, this is an A here, equals 12. What does A equal? Well, in this case, you would know, well, 2 times 6. The answer in this case would be 6, okay? And if I said 2A equals 20, you would go, well, 2 times 10. Yeah, the answer must be 10. And so all A means is 2, it means basically what? 2 times what? Okay, if you think of that letter, whatever it is 2 times what equals 10? Or if I said 2 plus y equals 10, you could go, well, 2 plus y equals 10. What plus 2 is, oh, it's 8. Y equals 8, okay? Because 8 plus 2 is 10. So all it is what? It's what number makes it equal, okay? What number is the one that would solve it and make it equal, this equal sign here? And that's really cool. That's really crucial. You're paying attention to the equal sign, okay? All right, so I wanted to kind of show you that because I wanted you to realize, don't stress if you see this equals, these letters now all of a sudden, and we won't get into much of this at all. We only have a week and a half to go, but I just wanted you to know that really it just means what? What number times 2 equals 10 or 12 or 20, okay? All right, you got another term here, which is an actual term, okay? And in algebra, or they're calling it a term, is a constant, which means a number, okay? We just learned that above, or a variable, which we learned is a letter, okay? Okay, so a term can be a constant or a variable, or the product or quotient of them. Product means times, okay? And quotient means division, okay? So these can all be terms. 5 can be a term. 5 can be a term because it is a constant. Or, you see how I capitalize or here, which means, okay, it can be that, or it could be a variable, a letter. There's a letter. That's a term. It's one term. And then it says, or the product of them. So now I've got a constant times a variable. That means it's the product of it. That right there is now a term, okay? Or 2x. There's a constant times a variable. That is a term, okay? So let's just a little bit of vocabulary. Please don't stress about it. You're not going to have to memorize these definitions for the test. And you'll have these notes in front of you for your homework. And you can look at your notes and refer to them for like the next exam as well, okay? All right. The last word on this page is an expression, okay? An expression is a mathematical phrase. It's one term or more than terms separated by plus or minus signs, okay? So in this example here, in fact, this is a better example right here. I'd like you all to make sure you write this in your notes here. 3x plus 5, that's an expression, okay? It's like half the equation. You see the equal sign here? There's got an equal sign here, okay? One expression is 3x plus 5, okay? So the definition says it's a mathematical phrase, and it's got a semicolon here. One term or more than one term separated by a plus or minus sign. So you kind of have two phrases here. Here's another phrase in a sense, okay? It's on the other side of the equal sign. Now, one way I think of it, because I'm an English teacher as well, is that I know that a phrase is not a complete sentence. A complete sentence has to have a subject and a verb and express a complete thought. So, and then it's a sentence. But, you know, you can have a phrase that's only part of a sentence. It's not the whole thing, okay? Likewise, an expression is like part of an equation. An equation has an equal sign in it, okay? But it's like one half of it. So this is called an expression, okay? 3x plus 5 and is an expression. All right, we're going to move on. We're going to do some practice here. All right, the last main term here for our notes here is this word I've already used now tonight a couple of times, is this term called an equation. There's just something about my brain that thinks this should be spelled with an S-I-O-N, but it's not. It's T-I-O-N, okay? And it's a statement that two expressions are equal, okay? They have an equal sign, all right? That is what they call an equation. So I'm kind of talking a little slower here, letting you guys copy this down. I've got the expression. This is my phrase here. It's not a complete sentence here. 2x plus 5 equals, okay, 15. When you see that equal sign, this word equals here, and two things separated by it, you're looking at an equation, and it's got, in the word itself, it's actually got the word EQU. It almost sounds like equal, okay? And it's when you see that equal, that's why it's called an equation. It's like it's an equation or something, okay? Something equals something. So you got an expression on one half of it, that's a phrase. Equals when it's something else, then the whole thing's called an equation, okay? All right, so for the rest of your life, when you see something that says something plus something minus something or whatever equals something else, oh, this is an equation. It's a complete sentence of algebra in a sense, like a complete sentence in English, okay? All right, another term we have here, which I'm sure you're busily trying to copy down here, is factors. And this is kind of review here, okay? This is, by now, you should have kind of known this somewhat, but I wanted to review this in the context of looking at expressions and equations, okay, as well. So you guys know in the number, if I take the number 6, it's got factors. 6 times 1 is 6, and 3 times 2 is 6. All four of those are factors of 6. Okay, they're the factors of, they're the things that are multiplied into 6. Okay, so we learned that before, that those are factors. Okay, now look at this. I'm looking at this thing right here. There's 2x plus 5 equals 15. Okay, in my brain, I see this equal sign. I know, oh, this is an equation. It's got equal in it. Okay, it's an equation. Okay, but if I ask you, which I will, and in your homework they ask you, looking at this problem, 2x plus 5 equals 15, tell me the factors. Okay, and this is why I wanted to apply this to algebraic expressions. Factors are things that are multiplied. Okay, that's what you can add to your notes here. They are things that are multiplied. That's what factors are. Okay, in this equation, because it's got the equal sign here, what are the factors? Okay. All right, I want you to look at it for a couple of seconds. What are the things that are multiplied that I could list as factors? Just like I did down here, I listed the things that multiply into each other, okay? Here's your answer. I got 2, and I'm going to put a comma here, and I got x. Those are the two things that are multiplied in this equation. Now, I want to be careful that I clarify. I didn't ask you what are the factors of 15. I ask you what are the factors in the equation? What are the things that are multiplied in the equation? And those are the two, okay? Let's look at another example here. Sorry about my writing here. This is supposed to be a B here, okay? 4y plus 2b equals 80. And if they ask you, if they said, please list all the factors in this equation, because it's got equal, that's called an equation, okay? I would list as an answer, I would write on my test or my homework, 4 is a factor, because I got 4 times y. I would put a comma, y is a factor. I would put a comma, 2 is a factor, and I would put a comma, b as in boy is a factor. Those are the 4 factors. They're why? Because they're the things multiplied times something else in the equation. Okay. Let me give you another example. If I ask you 7x plus 11, we'll call it v, equals 21 y. Okay. Could you list all of the factors in that particular equation? If you're thinking about it, what are all my factors, things multiplied? I would list 7 because it's multiplied by x, put a comma. 11 is multiplied by v, and 21 is multiplied by y. Those are things side by side next to each other. Like if I said 2 next to 3 like this, okay, that means 2 times 3, okay? They're side by side. Those are all my factors. Now, I should clarify, you could have they might ask, list all the factors in an expression, okay, which it might be 8a plus 2, okay? In that's an expression, that's a phrase. What are the factors? 8 and a, okay? All right, spent a lot of time on that. I hope that's pretty clear that you can have factors in a single number and you can have factors in an algebraic expression or an equation. All right, this concept on this slide should be a little bit of review as well, because I think I've touched on this quarter and you should have had it previously, but I wanted you to just kind of rewrite it in your notes as a reminder that there's something called an exponent. If you remember PEMDAS, PEMDAS, which stands, this is your order of operations. Do it's in parentheses first, then the exponents, then multiply and divide and add and subtract. And actually, technically, I'll tell you a little magical secret here that maybe you were never told before. But there's actually, even though there's 1, 2, 3, 4, 5, 6 things listed there, there's actually just 1, 2, these next two are kind of equal, okay? And these two are equal, add and subtract. So there's really four steps or four things in the order of operations technically. Do the parentheses first, then do the exponents, then multiply and or divide from left to right, and add and subtract. They're considered somewhat equal. All right. So anyway, 2 squared is 2 times 2. 3 squared, or 2 to the third, excuse me, is 2 times 2 times 2. And 3 to the fourth is 3 4 times. All right. Those are called exponents. This little number up here is the exponent of a number. And by the way, you can add this to the notes. I think we said this before, but some people will call this the bottom number, the base number in an exponent. The 2 as the base, and some people refer to it as the root number, but it's the base number. That's the base, and the exponent is the little number on top, okay? All right, moving on here. This one I'm going to give you a moment to copy down because it's kind of a little bit longer definition here. All right, so we're almost done here tonight, folks. I should be done hopefully in the next 10 minutes. Poly means many, nomials, okay, is a math term. It's just a math term, and it's an expression with one or more terms. We learned that an expression already. We learned that an expression is a phrase, okay, and so we learned that already. That's a phrase, okay, like 2x plus 5. An expression with one or more terms that are constants or products or variables and constants. That's a lot of language here. Trust me, I'm condensing what was in your textbook down to as little words as possible, as few words as possible, okay? So, but I do want you kind of to, in your notes, I want you to underline this concept because there'll be one question like this on your homework this week, okay? Exponents, if it has an exponent, like 3 to the 3 squared here, the exponent must be a whole number, okay? So I want you to kind of underline that because you will have one question like this. What I mean by that is it's got to be a whole number, not 3 to the 2/3 or something, okay? If the exponent was a fraction here, then I'm going to circle this and go, no, put an X through it, okay? Then it's not considered a polynomial if it has a number with an exponent that's a fraction. It's got to be a whole number like 2 or 3 to the third, okay? All right, and there's 3 different kinds of polynomials. There's a monomial, and mono in what the Latin means 1, okay? And it has one term, okay, like 2x. And we learned a few slides ago that 2x is a term, okay? That is, it's a constant or a variable or the product of or a quotient of a constant and variable. All right, a binomial, bi means 2, okay? Bi, so I'm gonna like do this in my notes. That means 2. Mono means 1. So 2 terms, okay? Like 2x, there's a term right there, plus something else. Like in this case, 5, that's a term. It's got 2 terms here, okay? So this is a 1-term thing. This is a 2-term thing. So it's called a binomial, okay? And then tri, you probably by now are catching on, means 3, okay? And it has 3 terms, okay? So 4x plus 3x plus 5, you'll see I've got 3 things separated by the plus thing. So I have 3 terms in my polynomial. So this is a 3 terms trinomial, okay? So when you see that in your homework and they ask you, is this a monomial, a binomial, or a polynomial? Just be aware of that, all right? Okay, it occurs to me that I might want to do a couple of practice problems here. So I'm going to get my book ready. Yeah. See page 114, number 6. Sorry, guys. Give me just a second here to, I just want to make sure what I want to do is practice a little bit so that we can kind of do this together. So, all right. All right. So anyway, but let's copy these concepts down here. We've got the concept of degree here, okay? And we're not talking about an antiperspirant, okay? There's one called degree, I think, okay? Like a deodorant. A degree is the highest exponent. That's what a degree is. It's the highest exponent, and that's the degree that it's to in a polynomial. So I'm giving you guys a few seconds to copy this down. So if I had the number 7, there's no exponent, so it would be considered 0 degrees because there's nothing, there's no exponent. If I had the number 7x, it now has a variable here, and we could call this 1 degree, okay? So we're kind of really paying attention to this variable here. I'm going to underline this. That's when we start getting degrees here, when we have this letter, this variable here. Notice 7 by itself, there's no variable, so it's 0 degrees, okay? 7x, it's not squared, it's not cubed or anything, so it's just 1 degree, okay? 7x squared, now the degree just matches up with the exponent. 7x to the third, it's 3 degrees, okay? You'll notice that those match, okay? 7x to the fourth, it's called 4 degrees, okay? And so I want to do a little bit of practice here. I'm going to write something on the screen here, and I will change colors just to be, I don't know, just to do this or not. Okay. If I have this practice problem here, and you can write this in your notes as well. I've got 5 minus 3y squared. Okay. All right. Now, first thing I want you to do is I want you to tell me, think about this. What type of polynomial is this? Is this a monomial, binomial, or a trinomial? Okay, think about it. Mono means 1 term. Binomial means 2 terms. Trinomial means 3 terms. I'm going to go back a slide so you see what they look like. See how you have a trinomial has 4x plus 3x plus 5. Okay, so if you're thinking that this is a binomial because it's got 2 terms, okay, that is correct. All right, all right. And identify the degree, okay? What degree do you see in this expression here? What degree is it to? Well, to find by degree, it's asking for the highest exponent. So by definition, there it is. So it would be considered 2, or I'll put down 2 degree. All right. I'm not talking about temperature here, but it'd be the 2nd degree, or 2. That's the degree in that question. All right. Let's look at another problem. I'll change color here just so things all stand out visually for you. Okay. And let's say I had 5n squared minus 9n plus 2. All right. First thing I'm going to ask you is, what type of polynomial is it? Monomial, binomial, or trinomial? By now, you're probably going, hey, teacher, that's pretty easy. I think I get it. Yeah, it's a trinomial, okay? It's got 3 terms in it, okay? What degree is it to? Well, it's the highest exponent. Again, in this case, that's a funny looking 2 there, but that is a 2. Sorry, my 2 it would be to the 2 degree, okay? All right, or degree 2. All right, let's do another one. Let's do this. Let's do number 3 here. Change color and go, what about right there? What if you had that? First of all, is that a monomial, binomial, or trinomial? How many terms does it have? It has one term, so it's a monomial. Okay. What degree is it to? What degree is it? Hint. Okay. All right. It doesn't have a exponent, so it's 0 degrees. Okay. All right. So for that problem, 0 degrees. Let's try another one. What about, let's see here. Here we go. Let's go number 4 here. What if you had x to the third plus x squared minus x minus 1. All right. What type of polynomial is that? Okay. Count terms. Okay. And, things separated by plus or minus here. Okay. I've got 1, 2, 3, 4 terms. Okay. So if they ask you on your homework, what type of polynomial is that? You're going to go, well, it's none. And your answer is none. You are right. It's really none of it's not a monomial, binomial, or a tri. It's a 4. So you just say none. Okay. It's not, none of those 3. And if they ask you what degree, okay, what is the degree of this problem? Okay. What is the highest exponent? My highest exponent's right here. That's it, 3 degrees. Okay. I'll just say 3D there. Okay. All right. And let's see here. And then what if I had something like this? If I had number 5 here, if I had x to the 2/3 plus 7 minus 2a. Okay. All right. If I ask you, is that a polynomial? Okay. By definition now, you'd probably look at that and go, you know what? The definition the teacher gave me on the previous slide said that the exponents must be whole numbers. Otherwise, it's not considered a polynomial. I'm going to look at that and say it's not a polynomial. Okay. And because it doesn't have a whole number in its exponent. Okay. How are we doing here? Last slide. Make sure I got everything. Oh, that is everything. Those are all the concepts. If you were paying pretty good attention here, we did a practice problem here on the end. I wanted to just kind of go through one and name the various kinds of trinomials, binomials, or monomials. If you were paying pretty good attention here tonight, I think you've got everything you need to be successful on your homework. And I do want, before I turn off my recording, I want to say to everybody that we've only got a week and a half. We got next week and is week 10, and then finals week. We just take the final. So I will be, the way it's going to progress is next week on Tuesday night. You want to make sure you're here because I'm going to warn you, it's probably the most confusing concept is the last two chapters. We'll get through it fine. I'll make it as simple as I can, but I just wanted to warn you, you'll really want to come pay attention. Or if you can't be here, be sure and watch the video. I'll make a recording. And then what I will do is the Tuesday night of finals week. Okay. So that's week 11. Okay. So not next week, but the week after it, I will have a Zoom class just like this, and we'll spend the whole hour and just practice. It's the third exam. We'll go through the whole thing, just like we did the other 2 exams, and you'll be ready to ace that exam number 3. Okay. All right.